Okay, in this section we're going to look at the binomial theorem. So it's all about expanding binomials, and we've done this before. Now we're going to, so we have formulas to expand like x plus y squared, x plus y cubed. We're going to use the binomial theorem to expand out binomials that have degrees higher than 3, 4, 5, So this is just going to be 1. Anything to the 0 power is 1. This will just come out to be x plus y. The next one will be x squared plus 2xy plus y squared. Alright, the next one, if you know the formula or don't, use the formula if you do. If not, you can take x plus y squared and multiply it by x plus y. I want you to pause the video and do that, and then when you unpause it, you'll have the answer right here. Okay, so if you expand out x plus y cubed, you should get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now I want you to pause the video again and look for any patterns that you notice and try to predict what x plus y to the fourth would look like without actually multiplying it out. So pause the video, take a minute to do that. Okay, so that's what x plus y to the fourth would be. And so a couple patterns that you should notice have to do with the exponents. For one, if you notice, like this first term here is always equal to the degree of the binomial. So like when you expand a binomial cubed, the first term is something to the third power. And x's go down by 1 each time until there's no x left, it's just x to the 0 power. Same thing with y. Alright, so y starts off to the 0 power and goes up by 1 each time. Okay, that's another thing important to notice. If you think of each term having an x and a y factor, those exponents are going to add up to n every time. So you got like 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4. Alright, and the most important thing, well, not really most important, I don't know if I should rank these by importance, but another really important thing are the coefficients. So it goes 1, and then 1 and 1, and then 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. Alright, and then if you were to do x plus y to the fifth, the coefficients would be 1, 5, 10, 10, 5, and 1. Now those numbers, if you don't recognize them, those are the values in Pascal's triangle. And Pascal's triangle is a triangle where the outer parts are all ones, and then to get the next numbers, you add the two numbers directly above it. So like 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 3 is 6, 1 plus 3 is 4, 1 plus 4 is 5. Alright, so on the next slide here, we have Pascal's triangle, and you could keep doing this forever. So, like we just said, if I was doing x plus y to the fifth, I could just do 1 x to the fifth plus 5 x to the fourth y plus 10 x cubed y squared, alright, and so on and so forth. Now, that's how you make Pascal's triangle. So if you wanted to find the sixth row of Pascal's triangle, what would you need to do? You might think you have to do the top 5 rows, but you can actually use your calculator or use something called combinations. So combinations we'll talk about in the next video. A little cliffhanger.